Hello students, and welcome to the lecture on Introduction to Data Communications and Networking. After the lecture, we will be able to learn the following objectives. Understand the concept of data communications. Describe networking with distributed processing. Explain the network models. Discuss the 7-layer OSI architecture of ISO. Explain the TCPIP reference model. Let's start with a brief introduction to data communications and networking. Data communications refers to the transmission of digital data between two or more computers and a computer network. Or data network is a telecommunications network that allows computers to exchange data. Data communications and networking are changing the way one does business and the way one lives. Business decisions have to be made ever more quickly, and the decision makers require immediate access to accurate information. The development of the personal computer brought about tremendous changes for business, industry, science, and education. A similar revolution is occurring in data communications and networking. Technological advances are making it possible for communications links to carry more and faster signals.
Let's start with simple data communication. Computer communication. Before we begin with the data communication between computers, let us first see that what a computer is. What is a computer? A computer is a programmable machine that is used to perform various computations. It is also used to store data in it. The computer has a characteristic of responding to a specific set of instructions in a well-defined manner, and it can execute a pre-recorded list of instructions called a program. The computers contain data in it. Data is a collection of facts such as values or measurements. It can be numbers, words, measurements, observations, or even just descriptions of things. When we want to share the data between two or more computers, called as data communication, it is required to form a network between them. The effectiveness of the data communication depends on three fundamental characteristics. Delivery. The system must deliver data to the correct destination. Accuracy. The system must deliver the altered and corrected data. Timeliness. The system must deliver the data in a timely manner. Data that is delivered late is useless. Now let's study different components of data communication. There are 5 components that are associated with the data communication. They are message, which is the data to be communicated; sender, which is the device that sends the data message; receiver is the device that receives the message; transmission medium is the physical link by which a message travels; protocols are the set of rules that governs data communication. Now let's see how to connect two or more devices. Two or more devices connect to a link, and two or more links from a topology. The types of topologies are bus topology, star topology, ring topology, mesh topology. Let's see each one in detail. Bus topology. A bus topology is a type of network setup where each computer and network device is connected to a single cable or backbone. Star topology. A star topology is one where each of the devices and computers on a network connect to a central hub. A major disadvantage of this network topology is that if the central hub fails, all computers connected to that hub would be disconnected. Ring topology. The ring topology is a computer network configuration where each network computer and device is connected to each other, forming a large circle. Each packet is sent around the ring until it reaches its final destination. Mesh topology. A network setup where each computer and network device is interconnected with one another, allowing for most transmissions to be distributed even if one of the connections go down. This topology is not commonly used for most computer networks as it is difficult and expensive to have redundant connection to every computer. Now let's see what a computer network is. A computer network is a collection of computers and devices connected to each other. The sender sends the request in the form of data packet, which is routed throughout the network. The network allows computers to communicate with each other and share resources and communication. The devices are connected with each other through wired and wireless connection. Then, the response of the request is routed back to the sender.
Let's now take a look at data communications. Data communications are the exchange of data between two devices via some form of transmission medium, such as a wire cable. For data communications to occur, the communicating devices must be part of a communication system made up of a combination of hardware, physical equipment, and software or programs. Components. A data communication system has 5 components. Message. The message is the information or data to be communicated. Popular forms of information include text, numbers, pictures, audio, and video. Sender. The sender is the device that sends the data message. It can be a computer, workstation, telephone handset, video camera, and so on. Receiver. The receiver is the device that receives the message. It can be a computer, workstation, telephone handset, television, and so on. Transmission medium. The transmission medium is the physical path by which a message travels from sender to receiver. Some examples of transmission media include twisted pair wire, coaxial cable, fiber optic cable, and radio waves. Protocol. A protocol is a set of rules that govern data communications. It represents an agreement between the communicating devices. Data representation. Text. In data communications, text is represented as a bit pattern, a sequence of bits, zeros or ones. Different sets of bit patterns have been designed to represent text symbols. Each set is called a code, and the process of representing symbols is called coding. Images. Images are also represented by bit patterns. In its simplest form, an image is composed of a matrix of pixels, picture elements, where each pixel is a small dot. The size of the pixel depends on the resolution. Audio. Audio refers to the recording or broadcasting of sound or music. Audio is by nature different from text, numbers, or images. It is continuous, not discrete. Even when one uses a microphone to change voice or music to an electric signal, one creates a continuous signal. Video. Video refers to the recording or broadcasting of a picture or movie. Video can either be produced as a continuous entity, for example by a TV camera, or it can be a combination of images, each a discrete entity, arranged to convey the idea of motion. Let's now take a look at data flow. Simplex. In simplex mode, the communication is unidirectional, as on a one-way street. Only one of the two devices on a link can transmit. The other can only receive. Keyboards and traditional monitors are examples of simplex devices. Half-duplex. In half-duplex mode, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, and vice versa. The half-duplex mode is used in cases where there is no need for communication in both directions at the same time. The entire capacity of the channel can be utilized for each direction. Full duplex. In full duplex mode, also called duplex, both stations can transmit and receive simultaneously. The full duplex mode is like a two-way street with traffic flowing in both directions at the same time. In full duplex mode, signals going in one direction share the capacity of the link, with signals going in the other direction. Let's now learn about networking. A network is a set of devices, often referred to as nodes, connected by communication links. A node can be a computer, printer, or any other device capable of sending and/or receiving data generated by other nodes on the network. Network hardware. In a network, computers and other optional devices are connected to share resources. When a computer or device A is requesting a resource from another computer or device B, the item A is referred to as a client. Networking hardware includes all computers, peripherals, interface cards, and other equipment needed to perform data processing and communications within the network. Network software. A general phrase for software that is designed to help set up, manage, and/or monitor computer networks. Networking software applications are available to manage and monitor networks of all sizes, from the smallest home networks to the largest enterprise networks. Software-defined network, or SDN, provides an end-to-end solution to automate the network from data center to campus and branch. Expanding the innovation of SDN, Ecosystem delivers resources to develop and create a marketplace for SDN applications. Distributed processing. Distributed processing is a phrase used to refer to a variety of computer systems that use more than one computer or processor to run an application. This includes parallel processing, in which a single computer uses more than one CPU to execute programs. Distributed processing refers to local area networks, or LANs, LANs, designed so that a single program can run simultaneously at various sites. Most distributed processing systems contain sophisticated software that detect idle CPUs on the network and parcels out programs to utilize them. Let's learn about physical structures. There are two possible types of connections: point-to-point and multi-point. A point-to-point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. Most point-to-point connections use an actual length of wire or cable to connect the two ends, but other options such as microwave or satellite links are also possible. Multi-point. A multi-point, also called multi-drop connection, is one in which more than two specific devices share a single link. Physical topology. The term physical topology refers to the way in which a network is laid out physically. Two or more devices connect to a link. Two or more links form a topology. The topology of a network is the geometric representation of the relationship of all the links and linking devices, usually called nodes, to one another. There are 4 basic topologies possible: mesh, star, bus, and ring. Mesh. In a mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between the 2 devices that it connects. To find the number of physical links in a fully connected mesh network with end nodes, one first considers that each node must be connected to every other node. Star topology. In a star topology, each device has a dedicated point-to-point link only to a central controller, usually called a hub. The devices are not directly linked to one another. Unlike a mesh topology, a star topology does not allow direct traffic between devices. The controller acts as an exchange. If one device wants to send data to another, it sends the data to the controller, which then relays the data to the other connected device. Bus topology. The preceding examples all describe point-to-point connections. A bus topology, on the other hand, is multi-point. One long cable acts as a backbone to link all the devices in a network. Bus topology was one of the first topologies used in the design of early local area networks. Ethernet LANs can use a bus topology, but they are less popular now. Ring topology. In a ring topology, each device has a dedicated point-to-point connection with only the 2 devices on either side of it. A signal is passed along the ring in one direction, from device to device, until it reaches its destination. Each device in the ring incorporates a repeater. When a device receives a signal intended for another device, its repeater regenerates the bits and passes them along. Let's now have a look at categories of networks. Local area network. A local area network, or LAN, is usually privately owned and links the devices in a single office, building, or campus. Depending on the needs of an organization and the type of technology used, a LAN can be as simple as 2 PCs and a printer in someone's home office, or it can extend throughout a company and include audio and video peripherals.
Hi, this is Mike Callahan, Dr. FileFinder, and welcome to your Butterscotch.com tutorial on what is a LAN. The term LAN stands for Local Area Network, and it generally refers to computers that are relatively close in proximity. It could be computers in the same home, it could be computers in the same office, it could be computers in the same building. But when you talk about a LAN, you're basically talking about computers that are relatively close to each other, that are connected and part of the same network. They can share printers, they can share servers, they can share documents and so on between each other. So a local area network is a type of network wherein the computers are in relative close proximity. And that's all there is to it.
Wide area network. A wide area network, or WAN, W-A-N, provides long-distance transmission of data, image, audio, and video information over large geographic areas that may comprise a country, continent, or even the whole world. A WAN can be as complex as the backbones that connect the internet, or as simple as a dial-up line that connects a home computer to the internet. One normally refers to the first as a switched WAN, and to the second as a point-to-point WAN. Metropolitan area networks. A metropolitan area network, or MAN, is a network with a size between a LAN and a WAN. It normally covers the area inside a town or city. It's designed for customers who need a high-speed connectivity, normally to the internet, and have endpoints spread over a city or part of a city. Let's now learn about the Internet. The Internet has revolutionized many aspects of our daily lives. It has affected the way one does business as well as the way one spends their leisure time. Perhaps one has sent electronic mail or email to a business associate, paid a utility bill, read a newspaper from a distant city, or looked up a local movie schedule, all by using the Internet. The Internet is a communication system that has brought a wealth of information to our fingertips and organized it for our use. In 1967, at an Association for Computing Machinery, or ACM meeting, ARPA presented its ideas for ARPANet, a small network of connected computers. The idea was that each host computer, not necessarily from the same manufacturer, would be attached to a specialized computer called an Interface Message Processor, or IMP. By 1969, ARPANet was a reality. 4 nodes at the University of California at Los Angeles, UCLA, the University of California at Santa Barbara, UCSB, Stanford Research Institute, SRI, and the University of Utah were connected via the IMPs to form a network. In 1972, Vint Cerf and Bob Kahn, both of whom were part of the core ARPANet group, collaborated on what they called the Interneting Project. Cerf and Kahn's landmark 1973 project outlined the protocols to achieve end-to-end delivery of packets. Transmission Control Protocol, or TCP, included concepts such as encapsulation, the datagram, and the functions of a gateway. International Internet Service Providers. At the top of the hierarchy are the international service providers that connect nations together. National Internet Service Providers. The national Internet Service Providers are backbone networks created and maintained by specialized companies. There are many national ISPs operating in North America. Some of the most well-known are SprintLink, PSINet, UUNet Technology, AGIS, and InternetMel. Regional Internet Service Providers. Regional Internet Service Providers, or regional ISPs, are smaller ISPs that are connected to one or more national ISPs. They are at the 3rd level of the hierarchy with a smaller data rate. Local Internet Service Providers. Local Internet Service Providers provide direct service to the end users. The local ISPs can be connected to regional ISPs or directly to national ISPs. Most end users are connected to the local ISPs. Let's now look at the 7-layer OSI architecture of ISO. The Open Systems Interconnect, or OSI model, has 7 layers. It explains the beginning with the lowest in the hierarchy, the physical, and proceeds to the highest, the application. Physical layer. The physical layer, the lowest layer of the OSI model, is concerned with the transmission and reception of the unstructured raw bit stream over a physical medium. It describes the electrical, optical, mechanical, and functional interfaces to the physical medium and carries the signals for all of the higher layers. Data link layer. The data link layer provides error-free transfer of data frames from one node to another over the physical layer, allowing layers above it to assume virtually error-free transmission over the link. Network layer. The network layer controls the operation of the subnet, deciding which physical path the data should take based on network conditions, priority of service, and other factors. Communications subnet. This layer relieves the upper layers of the need to know anything about the data transmission and intermediate switching technologies used to connect systems. It establishes, maintains, and terminates connections across the intervening communications facility, one or several intermediate systems in the communications subnet. Transport layer. The transport layer ensures that messages are delivered error-free, in sequence, and with no losses or duplications. It relieves the higher layer protocols from any concern with the transfer of data between them and their peers. The size and complexity of a transport protocol depends on the type of service it can get from the network layer. End-to-end layers. Unlike the lower subnet layers, whose protocol is between immediately adjacent nodes, the transport layer and the layers above are true source-to-destination, or end-to-end layers, and are not connected with the details of the underlying communications facility. Transport layer software and software above it on the source station carries on a conversation with similar software on the destination station by using message headers and control messages. Session layer. The session layer allows session establishment between processes running on different stations. It provides session establishment, maintenance, support, and termination. Presentation layer. The presentation layer formats the data to be presented to the application layer. It can be viewed as the translator for the network. This layer may translate data from a format used by the application layer into a common format at the sending station, and then translate the common format to a format known to the application layer at the receiving station. Application layer. The application layer serves as the window for users and application processes to access network services. This layer contains a variety of commonly needed functions like resource sharing and device redirection, remote file access, remote printer access, and inter-process communications. Let's now look at the concepts of layer protocols and layer interfaces. There are many functions which may need to be needed and performed by a protocol. These range from the specification of connectors, addresses of the communications nodes, identification of interfaces, options, flow control, reliability, error reporting, synchronization, etc. The protocols are usually structured together to form a layer design, also known as a protocol stack. All major telecommunication network architectures currently used or being developed use layered protocol architectures. The upper layers are sometimes known as middleware because they provide software in the computer which converts data between what the application's programs expect and what the network can transport. The basic idea of a layered architecture is to divide the design into small pieces. Each layer adds to the services provided by the lower layers in such a manner that the highest layer is provided a full set of services to manage communications and run distributed applications. A basic principle is to ensure independence of layers by defining services provided by each layer to the next higher layer without defining how the services are to be performed. Here we will discuss the TCPIP reference model. The TCPIP is based on a 4-layer reference model. All protocols that belong to the TCPIP protocol suite are located in the top 3 layers of this model. Each layer of this model corresponds to one or more layers of the 7-layer Open Systems Interconnection, or OSI reference model, proposed by the International Standards Organization, or ISO. Let's now have a look at the comparison of OSI and TCPIP reference models. The Internet Protocol Suite, also known as TCPIP, is the set of communications protocols used for the Internet and other similar networks. It is named from two of the most important protocols in it, the Transmission Control Protocol, which is TCP, and the Internet Protocol, or IP, which were the first two networking protocols defined in this standard. The TCP/IP protocols are considered to be standards around which the Internet has developed. The OSI model, however, is a generic protocol-independent standard. The TCP/IP is considered to be a more credible model. This is mainly due to the fact because TCP/IP protocols are the standards around which the Internet was developed. Therefore, it mainly gains credibility due to this reason. Whereas in contrast, networks are not usually built around the OSI model, as it's merely used as a guidance tool. The presumably strict consumer-producer layer of OSI, as it is usually described, does not present contradictions in TCP/IP, as it is permissible that protocol usage does not follow the hierarchy implied in a layered model. Now in the end, let us summarize what we have learned in this lecture. Data communications is the transfer of data from one device to another via some form of transmission medium. A data communication system must transmit data to the correct destination in an accurate and timely manner. The 5 components that make up a data communication system are the message, sender, receiver, medium, and protocol. Data flow between two devices can occur in one of 3 ways: simplex, half-duplex, or full duplex. A network is a set of communication devices connected by media links. In a point-to-point connection, 2 and only 2 devices are connected by a dedicated link. In a multi-point connection, 3 or more devices share a link.